Hello and welcome back again. So while we're at all this foundational stuff of understanding infrastructure as code, there's a few other concepts and terms we need to cover. Now, one term you may hear in the DevOps world, and especially in the context of infrastructure as code, is the term immutability. So what do we mean by immutable infrastructure in the scope of infrastructure as code here? Well, immutable infrastructure is the concept that once your resources are provisioned in your environment, that you don't make any changes to that resource after that point. So if we use a simple VM example here, that once that VM is deployed, we don't do any configuration changes on it or apply any security patches. Once it's deployed, that VM is essentially carved in stone and we don't touch it. Now, of course, we need to apply security patches to our operating systems and perform upgrades and install new versions of our applications. But instead of doing that on the existing VMs, we simply replace them. And this goes back to that whole cattle versus pets thing. We want our VMs and our infrastructure to be more like cattle and be able to easily replace them as needed. We can use our image templating tools to create a golden image with all the latest updates we need, then simply replace the running VMs or container instances with new ones based on that updated image. And next, we should understand the term idempotence and how it relates to infrastructure as code. So for our purposes, idempotence is just code that executes properly and results in the same outcome, regardless of how many times you run it. So for another simple example here, if we needed to add a line of text to a configuration file that's on 100 different virtual machines, doing this manually one by one would be very slow, tedious, and error-prone. So maybe we write a script to SSH into these virtual machines and run a command to append that new line of text to the file. But what happens if we run that script a second time? Depending on how that script was created, we may now have a duplicate line of text in that configuration file. If our script simply appends a text string as a new line each time that script is run, it does the same thing. So run the script and it adds a new line of text. Run it again, and another line of text is added. So the script in our example here isn't smart enough to really know that that line of text already exists. Now, maybe having this duplicate line of text in our configuration file may actually break the application that uses it and cause it to crash. So this is basically a non-idempotent script at this point. After every execution beyond the first time it runs, it creates an undesired result, and our configuration file is not in the expected state. Now, of course, that script could certainly be improved quite a bit to build in more logic and error handling to it, but that would take a lot of extra development time to perform a fairly simple action. And then when you think about some real-world scripts where you're just not adding a simple line of text, you may need potentially hundreds of different functions being performed, and then each of those functions may need a number of checks to understand the current state of the host, and then build in all the logic and error handling so you get the host into that desired configuration, regardless of its current setup. Now, most infrastructure as code tools, other than scripts, have this idempotence built in. So if you're using Chef or Ansible to manage your configuration file, you can add the desired line of text to it and have the tool remotely manage those 100 VMs to update that configuration file to match the desired state of that file. Then, no matter how many times that configuration file recipe or playbook is run by Chef or Ansible, it wouldn't keep modifying that same file over and over again. The existing state of the file on the VM matches what was defined in those tools, so there's nothing to do. Now, as a quick infrastructure example, say you have a simple environment where you need 2 web servers, 2 load balancers, and 10 backend application servers, and a database. If you have IAC code defining your environment, this is the state you always want your infrastructure to be in. Now, maybe one of your backend servers stops, it just stops running for some reason, and you need to replace it. So if you run your infrastructure code again and try to fix things up, you don't want it to deploy every resource again. You'd end up with 4 web servers, 4 load balancers, 19 servers, and 2 databases, and basically cause a big mess. We especially want our infrastructure provisioning tools to be idempotent to ensure we don't create a nightmare of duplicated resources and get our environments into an unhealthy state. Now, another concept to understand as we go forward in the course is imperative code versus declarative code. So with imperative programming, you're basically taking over the ship here. You control the operational flow end to end. You define the specific order different function execution steps take to accomplish your goal. Now with declarative programming, you're defining what your end state or end result should be instead. The application executing the declarative code has all the logic built in to figure out how to achieve that end result you defined. All the imperative specific control flows, the order of operations of all the dependencies involved, to get to that end result are all figured out for you by the tool. And this greatly simplifies the amount of development work needed by you to accomplish the same end result. Now, going back to our infrastructure as code tool categories, using scripts would be an imperative way of doing infrastructure as code. You have to create all the prerequisite checks to figure out the dependencies involved, then execute all the steps in a particular order to accomplish your goal. The other categories of tools are much more declarative in nature. You just define the end state of your virtual machine or container image, the configuration state of your resources, or the required infrastructure resources you need to be deployed. Then the infrastructure as code tool figures out all of those in-between steps to get your image or infrastructure resources into the desired end state. So in the lessons up to this point, we have a great base understanding of infrastructure as code concepts now, but let's start bridging all this to more Terraform-specific things. So in the next lesson, we'll get a better understanding of what specific problems Terraform solves in this infrastructure as code tool domain, and then later compare Terraform to some of the other tools around to help understand if it's the right tool for the job and the right tool for you. So see you in the next lesson.